Okay, welcome to Chapter 14, Section 1. Let's get right into the key ideas here. What does temperature have to do with energy? We just got through discussing energy in the last chapter. What three temperature scales are commonly used? What makes things feel hot or cold? Alright, start off with, what does temperature have to do with energy? The temperature of a substance is proportional to the average kinetic energy of the substance's particles. And if you remember, we talked about kinetic energy. Kinetic energy is the energy of motion. So there's a whole bunch of moving particles in objects, even solid objects that seem like they're not moving at all. All of their little particles in there are vibrating with some kind of motion. If you take the average kinetic energy of that, that's the temperature of the substance, or it's kind of proportional to that average kinetic energy. So temperature, a measure of how hot or cold something is, specifically a measure of the average kinetic energy of the particles in an object. So, all particles have kinetic energy. Particles are moving all the time. Our particles in a substance are constantly moving. As the average kinetic energy of the particles in an object increases, the object's temperature increases. So, common thermometers rely on something called expansion. Are things getting larger. So most substances expand when their temperatures increase, and a thermometer is an instrument that measures and indicates temperature by that expansion. Thermostats rely on the expansion of metals, because metals will expand and contract depending on temperature. So let's watch here a little bit on measuring temperature, this visual concept.
A thermometer is anything that changes in a measurable and predictable way when temperature changes. The most common thermometers use mercury or alcohol confined in a thin glass tube. As the thermometer is heated, the volume of the fluid increases. The relationship is roughly linear. We can create a scale for a thermometer with two known temperatures. Common reference points are usually things like the freezing point of water and the boiling point of water at standard pressure. Once these 2 points are identified on the thermometer, the distance between them can be divided into evenly sized intervals. These intervals are often called degrees.
Alright, so let's move on here. Temperature scales. What three temperature scales are commonly used? So you have the Fahrenheit, Celsius, and Kelvin temperature scales are commonly used for different applications in different parts of the world. Units on a Fahrenheit scale are called degrees Fahrenheit. On the Fahrenheit scale, water freezes at 32 degrees and boils at 212 degrees. The Celsius scale gives a value of 0 degrees to the freezing point of water and a value of 100 degrees to the boiling point of water at standard atmospheric pressure. 1 degree Celsius is equal to 1.8 degrees Fahrenheit. So the temperature at which water freezes differs for the two scales by 32 degrees. Fahrenheit Celsius conversion equations. So if you're going to convert between Celsius and Fahrenheit, these are the equations in which you would do so. If you have the Celsius temperature and you want to convert to Fahrenheit, you use this first one, which is 1.8 times the temperature in Celsius plus 32. And if you have Fahrenheit and want to transfer or convert to Celsius, you take the Fahrenheit temperature, subtract 32, and then divide by 1.8. And you see here that the identifiers of TF is the Fahrenheit temperature and TC is the Celsius temperature in these equations. So Kelvin scale, the third one, is based on something called absolute zero. Absolute zero is the temperature at which molecular energy is at a minimum. It's really when all molecular motion stops. It's virtually impossible to reach. We've gotten extremely close to reaching absolute zero, but it's virtually impossible to take all energy out of the system, especially even to monitor a system. You have to put energy into it just to monitor it. So it's kind of an impossible task. 0 Kelvin on the Kelvin scale, or negative 273.16 degrees Celsius on the Celsius scale. So Celsius Kelvin conversions, if you have the Celsius degrees, you can take it, add 237 to it, and that gives you the temperature in Kelvin. Alright, so let's watch this little video here.
A number of different temperature scales are in common use. In the United States, the Fahrenheit scale is commonly used for purposes of meteorology and medicine, as well as in most non-scientific areas. On this scale, the freezing point of water falls at 32 degrees, and the boiling point of water falls at 212 degrees. On the Fahrenheit scale, these two reference points are separated by 180 degrees. The Celsius scale is the most commonly used scale for scientific purposes the world over. It is also used for non-scientific purposes outside of the United States. On this scale, 0 degrees is the freezing point of water. 100 degrees is defined as the boiling point of water. The Celsius scale is also called the centigrade scale because it has 100 degrees between freezing and boiling. The Kelvin scale is widely used in physics, chemistry, and astronomy. The size of the degrees on the Kelvin scale is the same as on the Celsius scale. The only difference is in the specification of the 0 point. On the Kelvin scale, the freezing point of water is at 273.15 kelvins, and the boiling point of water is at 373.15 kelvins. This scale was invented after the concept of absolute zero temperature was discovered from the study of gases. As an ideal gas is cooled, its volume decreases linearly with temperature. It can be seen that the volume of an ideal gas would become zero when the temperature reaches minus 273.15 degrees Celsius. This is the temperature that is specified as zero on the Kelvin scale. It is absolute zero, the coldest possible temperature.
Alright, so let's move along here. Math skills. Let's do some temperature scale conversions. The highest temperature ever recorded in Earth's atmosphere was 57.8 degrees Celsius in Libya in 1922. Express this temperature in degrees Fahrenheit and in kelvins. So list givens. We have Celsius temperature at 57.8 degrees Celsius. Unknown is temperature in Fahrenheit and temperature in Kelvin. So write down the equations for the temperature conversions. Fahrenheit is 1.8 times the Celsius temperature plus 32, and for Kelvin it's the Celsius temperature plus 273. So we insert the known values in the equations and solve. For Fahrenheit, 1.8 times 57.8, and then add 32 to that gives you 136 degrees Fahrenheit. That is awfully hot. And then on the Kelvin scale, you take 57.8 and add it to 273, which will give you 331 kelvins. So relating temperature to energy transfer. What makes things feel hot or cold? The feeling associated with temperature difference results from energy transfer. When two objects that are at different temperatures are touching, energy will be transferred from one to the other. So temperature change indicates an energy transfer. And we have something called heat. Heat is the energy transferred between the objects that are at different temperatures. That transfer of energy as heat always takes place from something at a high temperature or hot to something at a low temperature to the cool side. And the greater in temperature or the greater in difference in the temperatures of the two objects, the faster the energy will be transferred as heat. Alright, so let's watch this video.
The temperature of a substance or object is proportional to the kinetic energy of its atoms or molecules. Objects at low temperatures often feel cold, while objects at high temperatures often feel hot. The particles of an object at low temperatures have low average kinetic energy. The particles of an object at high temperatures have high average kinetic energy. When two objects with different temperatures are in physical contact, a transfer of energy occurs. Heat is the energy transferred between objects because of the difference in their temperature. The natural flow of energy is always from the hot to the cold object, until both are at the same temperature.